Hi guys, welcome to this lesson. So in this lesson, we want to look at angle between two lines. If you remember, in the previous lesson, we have considered angle between two lines where we define it to be cos theta equals to a dot b all over magnitude of a magnitude of b. So it is what we said there was angle between two vectors. So you know that vectors are also in other way a straight line. So that formula can also be used to calculate the angle between two lines. So the angle between two lines is defined as the angle between their direction vectors, which is the same formula we used in the previous one. Cos theta equals to a dot b all over magnitude of a magnitude of b. Okay, so where in this case, you know that the point on the line is a, okay, and the direction of the line is b. Okay, so that's the only difference we have here. So let's see how the example goes. So find the acute angle between the two lines. Okay, so we have two lines here, so let's find the acute angles. Dot this. So find the acute angle. This is example 4. Find the acute angle between the two lines. Okay. So look at the lines. So we are not going to be using the position. Okay. What we are going to use is the direction. Okay. So let's take our direction. So we have B1 equals to 215 and B2 equal to minus 341. Okay. So B1 dot B2 equal to 2 minus 3 plus 1 times 4 plus 5 times 1, and that is minus 6 plus 4 plus 5, which is minus 6 plus 9, that's 3. So that's the dot product. So we need to find the magnitude. So the magnitude of B1 is magnitude of B1, we have a square root of what? Square root of 2 square plus 1 square plus 5 square, which is square root of 4 plus 1 plus 5, which is square root of 10. Magnitude of B2 equals to square root of minus 3 square plus 4 square plus 1 square, which is square root of 9, 9 plus 16 plus 1, which is square root of, this is 10, square root of 26. So the next thing is to calculate the angle cos theta equals to a, what did we use? We used b1 dot b2 all over magnitude of b1, magnitude of b2. Okay, and that is going to be, what was our b1 dot b2? That is 3. So we're going to have 3 all over square root of 10 multiplied by square root of 26, okay, which is 3 all over square root of 260. So let's take our calculator and find the value. Cos theta equals to, take your calculator guys and let's check it together. So cos theta equal to 3 divided by root 26, and that is equal to 0.5883. So theta equals to cos inverse 0.5883. So cos inverse of the answer, that would be equals to 53.96. So therefore theta equals to 53.96 degrees. So theta is approximately equals to 54 degrees. Okay. So this is how you find the angle between two lines. Okay. You use their direction, not the position. Example 5, we have this. So we have that, let's say we have S1 equal to 1 minus 1, 1, and S2 equal to 1, 2, 3. Okay, so s1 dot s2, that will be equal to 1, 1 plus minus 1, 2 plus 1 times 3, and that is going to be 1 minus 2 plus 3, which is a 4 minus 2, and that is 2. So this is the dot product, and then we can find the other product. So we have magnitude. Magnitude of x1, that will be square root of 1 square plus minus 1 square plus 1 square, which is square root of 3. Okay. Magnitude of s2 equals to square root of 1 square plus 1 square plus 2 square plus 3 square, which is square root of 1 plus 4 plus 6, which is square root of 11. Okay, so we then imply that cos theta equals to x1 dot s2 all over magnitude of s1, magnitude of s2. So we have that will be s1 dot s2 was our answer, 2 all over magnitude root 3 multiplied by root 11, which is 2 all over root 11. Okay, so therefore cos theta equal to, so what's 2 divided by 2 root 11, guys? 2 divided by square root of 11. So shift cos inverse of the answer. So that will be equal to 0.60330. So therefore cos theta, or theta, equals to cos inverse of 0.6030. So what's the cos inverse of the answer? We have 52.91 degrees. So theta equals to 53 degrees approximately. So this is what we have, and this is how to find all those things. Okay, so let's see if we have more question there. Okay, so I'm going to, let's see if this is the remaining one. Right, so you can try these questions out, guys. So do this as classwork, use the same method, classwork. So let's see if we have the same. Show that the following two lines are perpendicular. That is, show that a1 b1 a2 b2 a2 b2 equals to 0. So let's do this together. So let's say we have b1 equals to minus 2 minus 2 minus 4 5, and b2 equals to minus 11 minus 2. Remember, for lines we use the direction to calculate the angles, not the points. Okay, so here we're going to have that b1 dot b2 equal to, or this, minus 2 minus 4 5 minus 11 3 minus 2. Okay, which is minus 2 multiplied by minus 11 plus minus 4 multiplied by 3 plus 5 multiplied by 2. So, and that will be 22 minus 12 minus 10. And that is equal to 22 minus 22, which is equal to 0. So it satisfies the condition. So remember that when two lines are perpendicular, their dot product equals to 0. So we check that b1 dot b2 equal to 0. So b1 is perpendicular to b2, or the lines are perpendicular. Let's use r instead. R1 is perpendicular to R2. Okay. So make sure you do your classwork, and in the next lesson we'll be looking at the distance from a point to a line. See you there. Bye.